start with background of study. Crude oil is a defining force in Middle Eastern economies. The region holds huge reserves and many national budgets depend on hydrocarbon revenue. So, when Brent crude prices move, it ripples into government spending, trade, employment and growth. We have seen this recently with geopolitical shocks pushing oil price up and the IMF cutting regional growth forecast. History confirmed this pattern. Vohra 2017 study showed GCC economies boom and burst with oil prices, but the impact isn't uniform. It depends on trade openness, FDI, inflation and labor conditions which vary by country. That's why our study used a 1990-2024 panel dataset combining Brent oil price with GDP growth, inflation, unemployment, trade and investment data across the region. Given government, investor and researchers update evidence on how these economies respond to oil shocks. The study is guided by 5 key objectives. First, we want to describe the trend of macroeconomic indicator that GDP growth, GDP, inflation, unemployment, trade, and oil prices across Middle Eastern countries over time. Second, we aim to determine whether the average GDP growth rate of this country is significantly different from a benchmark growth rate. The third one is, we examine whether there's a significant difference in GDP growth between oil price shock periods, comparing high oil price years against low oil price years. Fourth, we look at whether GDP growth rate differs significantly across different GDP growth categories, low, medium, and high. And the last one is, we determine the effect of Brent oil prices and other macroeconomic indicators, export, FDI, inflation, and unemployment on the GDP growth rate. Together, these 5 objectives move from simply describing the data to testing specific hypotheses and finally to modeling the relationship between oil prices and economic performance.
Now, let's move on to the description of our data. This research focuses on the impact of Brent oil prices on macroeconomic indicators in Middle Eastern countries, covering the period from 1990 to 2024. Our element unit is the country year observation, meaning each data point represents one Middle Eastern country in one specific year. For our population, we are looking at all annual macroeconomic records of Middle Eastern countries covered by the dataset. This gives us 13 countries across 35 years, totaling 455 country year observations. However, not every observation had complete data, so after this was division of missing values, our actual sample size is 447 observations for the GDP growth related test and 427 observations to the regression model. Our sampling frame is the Middle East economic and oil prices dataset, which was compiled from World Bank records and Brent crude oil price data. In terms of sampling technique, we use complete enumeration, meaning we included all available country year records as secondary panel data with no additional sampling performed. Finally, our source of data is secondary data and it was collected through data extraction from the Kaggle repository titled Middle East Economic and Oil Prices 1990 to 2024. Next, we will go through our method of analysis, which is organized according to our 5 research objectives. Our first objective is to describe the trend of key macroeconomic indicators, including GDP, GDP growth, inflation, unemployment rate, and Brent oil price across Middle Eastern countries. For this, we use descriptive statistics such as mean, standard deviation, minimum, and maximum, along with trend analysis presented through tables and graphs. Our second objective is to determine whether the average GDP growth rate of Middle Eastern countries is significantly different from a benchmark growth rate. For this, we applied a one-sample t-test using GDP growth rate as our variable. Our third objective examines whether there is significant difference in GDP growth rate between oil price shock periods, specifically comparing high oil price years versus low oil price years. This involves GDP growth rate and oil price shock as our variables, and we use an independent sample t-test. Our fourth objective looks at whether GDP growth rate differs significantly across different GDP growth categories, low, medium, and high. For this, we use a one-way ANOVA. And finally, our fifth objective is to determine the effect of Brent oil prices and macroeconomic indicators such as export, FDI, inflation, and unemployment on GDP growth rate. Here, GDP growth rate is our dependent variable, while Brent oil prices, export, FDI, inflation, and unemployment serve as independent variables. For this, we conducted a multiple linear regression analysis. To carry out of this analysis, this study uses JASP, which stands for Jeffrey Amazing Statistics Program. JASP is a free, open-source statistical software that offers a user-friendly interface for conducting various types of statistical analysis, and it is well-suited for both descriptive and inferential statistics. Specifically, in the study, JASP was used for 5 main purposes. First, to generate descriptive statistics, including the mean, standard deviation, minimum, and maximum values of our variables. Second, to perform a one-sample t-test comparing the average GDP growth rate against our benchmark value. Third, to conduct an independent sample t-test comparing GDP growth rates between high and low oil price periods. Fourth, to perform a one-way ANOVA, examining differences in GDP growth across different growth categories. And fifth, to conduct a multiple linear regression analysis, determining the effects of Brent oil prices, export, FDI, inflation, and unemployment on GDP growth rate. Beyond running this test, JASP also provides us with tables, graphs, and statistical outputs, which help us interpret and present our research findings accurately and clearly.
Alright, so before we get into any of the hypothesis testing, we wanted to just get a feel for the data first. Now let's start with the GDP growth. On average, it's sitting at about 4.44% at a year, which honestly isn't bad. But here's the thing that jumped out at us: the median is only 3.88%, and that gap between the two tells you something's off. It means a handful of really strong growth years are dragging that average upward, while most of the time growth was actually a bit more modest than 4.44%. Makes it sound. Now we go to the inflation, and this is where it gets interesting. The average inflation rate is 11.57%, but the median is just 3.3%. That's a huge gap. What that's telling us is that most years, inflation in the region was actually pretty tame. around 2 to 3%. But there were clearly some extreme episodes, maybe currency crisis or fiscal shocks in specific countries, that pulled that average way up. Unemployment, by comparison, is actually the most normal or well-behaved. All the variables that we have right now, mean and median are both right around 7%, so there's no weird skew going around here. So the labor markets in the region seems to move a lot more steadily than growth and or inflation do. Then we've got exports and imports, both hovering in the 40% range, and again that means the means a little higher than the median for both, so a bit of that same positive skew shows up. And it makes sense because some Gulf economies are way more fact dependent than the others, so you get that split. And finally, we have the start of the show here is the Brent oil price. The average is $57 a barrel, but the most frequently occurring price was actually $74. So the typical price experience was actually higher than the average. And the average just got pulled down by the periods where oil crashed hard like 2014 to 2016 or the COVID crash in 2020. And honestly, that swing a standard deviation of over $26. And that says everything about how wild the oil market's been over this period.
Now, let's move on to the one sample t-test. This test is used to determine whether the average GDP growth rate of Middle Eastern countries is significantly different from a benchmark growth rate, which in this case is set at 3%. The results show a mean GDP growth annual of 4.443% with a p-value of 3.320, different of 445.46, and a p-value of less than 0.001. Now, let's go through the analysis step by step. Step 1, we state the statistical hypothesis. The null hypothesis H null states the MU equal to 3, while the alternative hypothesis H1 states that MU is not equal to 3. Step 2, we use the p-value method with alpha set at 0.05. Step 3, we test the hypothesis and the p-value obtained is less than 0.001. Step 4, we make the decision since the p-value which is less than 0.001 is smaller than alpha 0.05, we reject H null. Step 5 is the conclusion. There is no sufficient evidence to indicate that the average GDP growth rate of the Middle Eastern countries is significantly different from the 3% benchmark. The positive mean difference of 1.443 percentage points shows that on average GDP growth in the region has outpaced this benchmark over the study period. This tells us that overall Middle Eastern countries have shown stronger economic growth performance than what the benchmark rate would suggest. Next, let's look at the result for the independent sample t-test. First, in terms of group descriptive, we have two groups, the high oil price years and the low oil price years. For the high group, the sample size N is 268 observations with a mean GDP growth annual of 4.017%, a standard deviation of 6.177, a standard error of 0.3773, and a coefficient of variation of 1.538. For the low group, the sample size N is 179 observations, which with a higher mean of a 5.082% but a much larger standard deviation of 12.40, a standard error of 0.9265, and a coefficient of variation of 2.439. This shows that the variability of data within the low group is much higher compared to the high group. Before we proceed with the t-test, we first need to check the test of equality of variances using leaving test. The result shows an F value of 11.78 with the F1 equal to 1 and the F2 equal to 445 and a p-value of less than 0.001. Since the p-value is very small and less than alpha 0.05, this means the variances between the two groups are significantly unequal. Next, we look at the actual independent t-test result. The t-value is negative 0.201 with the F of 445 and a p-value of 0.230. Now let's walk through the analysis of the result in 4 steps. Step 1 is the test for equality of variance using leaving test. The null hypothesis H null state that the sigma 1 equals sigma 2, while the alternative hypothesis H1 state that sigma 1 is not equal to sigma 2 at a significant level of alpha 0.05. Since the p-value is less than 0.001, which is smaller than alpha 0.05, we reject H null. This means the variances of GDP growth in the high and low oil price period are significantly unequal. Step 2, we state the statistical hypothesis for the actual t-test. H null state that MU1 equal MU2, while H1 state that MU1 is not equal to MU2. Step 3, we make the decision. Since the p-value is 0.230 and this is greater than alpha 0.05, we do not reject H null. Step 4 is the conclusion. There is no sufficient evidence to indicate a significant difference in GDP growth rate between high oil price years at 4.017% and low oil price years at 5.082%. This means that although there appears to be a numerical difference in means between the two groups, statistically this difference is not strong enough to be considered as significant.
Next, I will explain to you the test result of ANOVA test. The purpose of this test is to determine whether the average annual GDP growth is significantly different across the three growth categories, which are low, medium, and high. First, we state our hypothesis. The null hypothesis, or H null, states that the mean GDP growth of all three categories is the same. The alternative hypothesis, H1, states that at least one category has a different mean GDP growth. From the ANOVA table, we obtain an F value of 101.7 with a P value of less than 0.001. Since the p-value is much smaller than our significant level of 0.05, so we reject the null hypothesis. This means there is a strong statistical evidence that the average GDP growth is not the same across all three growth categories. In other words, countries classified as low, medium, and high growth have significantly different average GDP growth rates. However, ANOVA only tells us that a difference exists. It does not tell us which groups are different. To identify that, we need to perform a post-hoc analysis, which is shown in the next slide. For our next slide, we have the post-hoc comparison test result. The purpose of the post-hoc test is to determine which specific growth categories differ from one another after the ANOVA showed an overall significant difference. Looking at the table, we compare high versus low, high versus medium, and medium versus low. For all three comparisons, the p-values are less than 0.001, indicating that every comparison is statistically significant. This means that each growth category has a significantly different average GDP growth from the others. Specifically, the high growth category has the highest average GDP growth, followed by the medium growth category, while the low growth category has the lowest average GDP growth. It is also important to note that these categories were created directly from the GDP growth values. Therefore, this result mainly confirms that the grouping method successfully separated countries into three statistically distinct categories. Overall, we conclude that the GDP growth differs significantly among the low, medium, and high growth group, with every pair of categories showing a significant difference.
Next, let's look at how Brent oil prices relate to export and foreign direct investment using Pearson's correlation. All the relationships we found are statistically significant. Since every p-value is below 0.001, starting with export, the correlation between Brent oil price and export as a percentage of GDP is 0.2539. That's a weak positive relationship. Similarly, the correlation between Brent oil price and FDI net inflow is 0.2078, also weak but positive. So what does this tell us? Across the panel, higher oil prices are weakly associated with higher trade openness and higher foreign investment inflow in Middle Eastern economies. This makes intuitive sense. Oil exporting countries tend to earn more and invest more when oil prices rise. That said, it's important to stress the word weak here. This correlation confirms a real relationship exists, but oil prices alone don't drive most of the variation in export or FDI. Other factors are clearly at play too. Let's move into our regression analysis, where we test whether FDI net inflow and export can predict Brent oil prices. We start with a baseline model M0, which has no predictors. This is just our reference points. With an R squared of 0, then in M1, we add FDI net inflow and export as predictors. This gives us an R of 0.291 and R squared of 0.085, meaning these two variables together explain about 8.5% of the variance in Brent oil price. The adjusted R squared, which accounts for the number of predictors, is very close at 0.081. The R squared change of 0.085 is statistically significant with P less than 0.001. So adding FDI and export does significantly improve the model compared to having no predictor at all. But notice the RMSE, our prediction error, only dropped slightly from 26.05 to 24.98. So while the improvement is statistically significant, it's fairly modeled in practical terms. This ANOVA table tells us whether the overall regression model is meaningful. Our regression sums of square is 2.455 times 10 to the 4th with 2 degrees of freedom. Our residual sum of square, the unexplained part, is much larger at 2.645 times 10 to the 5th with 424 degrees of freedom. This gives us an F statistic of 19.67 with a p-value less than 0.001. That's statistically significant, so FDI net inflow and export taken together do predict Brent oil price significantly better than change. That said, look at the size difference between the regression and residual sum of square. The residual is much larger, which confirms what we saw in the model summary. Most of the variation in oil price is still left unexplained by just these two variables. Finally, let's look at the actual regression equation and what each predictor contributes. Our fitted equation is predicted oil with price equal 44.03 plus 1 time FDI net inflow plus 0.2658 times exports. The intercept is 44.03. That's the predicted oil when both FDI and export are 0, and it's highly significant with P less than 0.001. For FDI, net inflow, the unstandardized coefficient is 1, meaning a 1 percentage point increase in FDI as a share of GDP is associated with a $1 increase in oil price per barrel, holding export constant. This is significant with P equal 0.002. For export, the coefficient is 0.2658. So, 1 percentage point increase in export as a share of GDP is associated with about a 27-cent increase in oil price per barrel, holding FDI constant. This is also significant with P less than 0.001. And notice its standardized beta 0.2248 is actually higher than FDI 0.1459, meaning export is the stronger predictor of the two. So, in summary, both FDI and export are statistically significant positive predictor of Brent oil price, and the overall model itself is significant. However, the practical explanatory power is still low, only 8.5%. This tells us that other factors we haven't included, like global supply and demand, or PEC policy, and geopolitical event, likely account for most of the movement in oil prices.
Okay, so to wrap all of this up, what were we actually trying to find out here? Starting with the first objective, honestly, this was just us getting a feel for the data, and what we found was that almost nothing in this data set behaves normally. Inflation and oil prices especially were all over the place, and not because that's the everyday experience, but because a handful of extreme years like oil crashes or inflation spikes are dragging the averages around. So for the second objective, in this one's kind of we expected more, honestly, moment. So we tested whether the region's average growth 4.4% was actually different from a 3% benchmark, and statistically it wasn't. The p-value was 0.23, way above our 0.05 cutoff, so we couldn't say with confidence that growth is really above that benchmark, even though the number itself looks higher on paper. The third objective was the most surprising result for us, and we figured that high oil prices should obviously mean stronger growth for oil-heavy economies, right? But the data said no. There was no significant significant difference in growth between oil price years and low oil price years. And when we talk about why, it actually makes sense. And because a lot of these governments have sovereign wealth funds and reserves specifically built to smooth things out, so short-term oil swings don't necessarily hit growth right away. Now we go to the objective 4, where we did find something solid. GDP growth clearly differs across low, medium, and high growth categories, and that difference was highly significant. And now, to be fair, this is a little bit of a yes, obviously result, since those categories were literally built from the growth numbers themselves. But it does confirm the groupings are real and distinct. Finally, the last objective is where we tested whether exports and FDI could predict Brent oil prices. And yes, the model was significant, but it only explained about 8% of the story, which honestly tells us oil prices are being driven by way bigger forces.
Based on our findings, we have 4 recommendations. So for the first recommendation, governments should continue strengthening their financial reserve and budget planning. This can help protect the economy when oil prices suddenly increase or decrease. Second, policymakers should focus on improving other areas of the economy such as infrastructure, education, and investment. Our results shows that the economic growth depends on more than just oil prices. Third, countries should diversify their economies by increasing export and attracting more foreign direct investment. This reduces dependence on the oil industry and supports more stable long-term economic growth. Lastly, future studies should use GDP growth as the main outcome and include more factors such as oil prices, exports, foreign direct investment, inflation, and unemployment. So this may provide a better understanding on what affects economic growth. Overall, these recommendations can help countries build stronger and more sustainable economy.